Alright, so we've got linear relations in standard form that we're going to talk about today. So a linear relation is any time that we've got an ordered pair or sets of ordered pairs that form a straight line. We call that a linear relation. And biggest part of the time we will have linear equations written in standard form. Standard form looks like this. Some number a times x plus some other number b times y is equal to c. Alright, so if you look down here, it says a, b, and c are integers. So you've got to make sure whenever you've got these in standard form that a, b, and c are all integers. There are no fractions whenever we write these. And a has to be greater than or equal to 1. A cannot be a negative number. So whatever number is in front of your x cannot be negative. And also, they have to be simplified as far down as they can be. The greatest common factor between a, b, and c can only be a 1. All right. So let's see how to rewrite these things and what we need to do with them. So we're going to write each equation in standard form. So it looks pretty close to what our definition is up here. We just need to make sure of everything. So a, b, and c, are they integers? -5, 6, and -12. All right, so those are integers. So is a greater than or equal to 1? All right, so a, this number in front of the x, is -5. So it can't be negative. This one can be negative and this one can be, but this number here in front of your x cannot. So to get it to be positive, all I'm going to do is divide everything by -1, and that's just going to flip my signs around, and we'll have 5x minus 6y is equal to 12. Alright, so let's check it again. A, b, and c are integers. Yes, yes, yes. Is a greater than or equal to 1? It is. It's 5 now. And are a, b, and c are the greatest common factor 1. So 5, 6, and 12. Yeah, the greatest common factor between all three of them is 1. So now this one is in standard form and we're good to go. So what happens whenever we've got y is equal to 2x minus 9? I want to write it in standard form. To do that, I have to solve it. Okay, so we're going to move stuff around. We'll subtract 2x from both sides, and I'll have minus 2x plus y is equal to -9. So go back up here, double check. Is it in standard form? A, b, and c integers? Yes. -2, a 1, and -9. So is a greater than or equal to 1? A is -2, so I'm going to have to flip my signs. So divide by -1, and then we get 2x minus y is equal to 9. So integers, they're all integers. A is greater than or equal to 1 now, and the greatest common factor between 2, 1, and 9 is 1. So that's true. So we're good to go with that. So next problem, 9x plus 6y minus 24. It has to look like this. This is some number times y, some other number times x. So to get it in standard form, I'm just going to add 24 to both sides. So now I have 9x plus 6y is equal to 24. Now, are each one of them an integer? A is an integer, b is an integer, c is an integer. So is a greater than or equal to 1? Yeah, it's +9. So is the greatest common factor of a, b, and c 1? No. The greatest common factor between 9, 6, and 24 is 3. So I'm going to divide the whole thing by 3. So how did I know that the greatest common factor was 3? After a while you can recognize the numbers and know that each one of them has a 3 in common with each other. Or there's a function on your calculator, on the Casio calculators, I think, called greatest common factor, and you can plug your numbers in there and it will evaluate it for you. So do your simplifications. 9 divided by 3 is 3. 3x plus 2y, and 24 divided by 3 is 8. So now these are all in standard form. So 7y is equal to 7 minus 7x. Write it in standard form. I am going to add 7x to both sides. So 7x plus 7y is equal to 7. Remember, x's and y's are on the left, and then just a number is on the right. So they're all integers, and the a value here is greater than 1. So what's the greatest common factor between 7, 7, and 7? It's a 7. So divide everything by 7, and you get x plus y is equal to 1. So here's my solution. That one's a solution, that one, and that one. Alright, so number 5. It's pretty close to being what we need, alright, except A and B are not integers, but A is greater than 1, so we don't have any greatest common factors yet. So how am I going to get rid of these fractions? This is what you do. If you've got different numbers here, after you get it set up like this, x and a y, multiply the denominators together. 4 times 3. That's going to give me 12. Okay, so 12 is a common factor, or is the product of both of those numbers. So if I go through and I multiply everything by 12, 3/4 x minus 1/3 y, and you've got to multiply this side by 12 as well. All right. So 12 times 3/4. 12 divided by 4 is 3. 3 times 3 is 9. So 9x. And then 12 divided by 3 is 4. So 4 times 1 is 4. So minus 4y. And that is equal to 12. Alright. To watch this a couple of times and figure out what I just did with this. I went through it kind of quick with my fractions, but watch it and see if you can figure out exactly what I did with that, because that's a really good trick to know for later on. Alright, so 1/6 x equals y minus 2. We'll do it another way here. I've only got this one fraction here. So I'm going to get rid of this fraction by multiplying the entire equation by 6. So 6 times 1/6 x is equal to 6 times y minus 2. So 6 times 1/6 gives me 1, so that is equal to x, 6y minus 12. Alright, so let's subtract 6y from both sides. And x minus 6y is equal to negative 12. So is it in standard form? Alright, I've got an integer, another integer, and another integer. Is a greater than or equal to 1? Yes, it is a 1. What's the greatest common factor between 1, 6, and 12? 1. So we're good to go with this. So the next that we've got, slope-intercept. We write equations in actually 3 different ways, but we are just going over 2 of them right now. So for slope-intercept, it looks like this. Y is equal to mx plus b. Or, like we did yesterday with our function notation, f of x is equal to mx plus b, where m is the slope and b is the y-intercept. So the slope is the constant rate of change between the points, rise over run, and there are 4 types of slope. So if you remember these 4 pictures here, you can tell me a lot about a problem really fast if you just memorize what these things look like. So we've got a positive slope, a negative slope, a slope of 0, and an undefined slope. Alright, so a positive slope is if you're coming from the left, it's going up towards the right. If you've got a negative slope coming from the left, you're going down to the right. So uphill, downhill. If you've got a slope of 0, you've got another horizontal line. So anytime you see a horizontal line, you know that its slope is 0 because you're not going up or down. You're not rising or running over anything. You're just going straight across. Undefined is a straight up and down line, or a vertical line. So you can know a lot about a function and what it's doing from just looking at the graph. This is important. Positive, negative, 0, undefined. Know that whenever you see an equation, if m is positive, then your graph has to go up to the right. If this m is negative, it's going down to the right. If you don't have an x in your equation, it's just a b, then it is a horizontal line. All right. Alright, so our directions here are to write the equation in slope-intercept form, and then we're going to graph the line. And this is why it's handy to know what these m's and b's are telling me, is because I don't have to do a lot of computation to be able to graph a line. So I'm going to identify the y-intercept, okay? If I can't remember, I just write y equals mx plus b underneath it, and then I compare what I've got. So m is this 2/5, and b is this 7. So my slope, m, is 2/5. And my y-intercept is b, which is 7. So this is what you do with that information. I want to graph this line, but I don't want to do a lot of computations. So with this y-intercept, I'm going to plot me a point on x equals 0, which is right here in the middle, and then 1, 2, 3, 4 at y equals 7. Alright, so I've got a positive slope, so I know that it needs to go, my graph needs to be going up this way after I get through with it. But I don't have enough graph to do it. So what I'm going to do is I'm going to go down to 1, 2, and then I'm going to go to the left 5. So 1, 2, 3, 4, 5. There is my other point. And then we'll graph us a straight line through it like that. Alright. So my slope for this line, there's a negative x, there's a negative 1 in here, so I'm going to say my slope m is equal to negative 1. And then my number is 2, my y-intercept is 2. So we're going to go over here and we're going to graph it. Y-intercept is 2. So on my y-axis, I'm going to draw a point at 2. And this is my starting point. You've got to do your y-intercept before you can do your slope. So my slope is negative, So I know that it has to go down 1 and then over 1, or that it's going to have to go downhill. So my slope is -1, so I'm going to go down 1, over 1, and there's me a point. And sometimes it doesn't hurt to do 2 or 3 of them. That way you can make sure you're getting you a good looking line. And then after you do that, all you do, draw your line. So see, negative slope, my graph's going down to the right. Positive slope, up to the right. So make sure when you're doing these things that you're paying attention to what this graph is doing, right? So for me to be able to pull out the slope and the y-intercept, I have to have it in slope-intercept form first. This is not slope-intercept form. This is standard form. So to get it in slope-intercept form, I need to solve this equation for y. Y has to be isolated. So that is going to be by itself by the time I get through. So I will subtract x from both sides. I get 3y is equal to -x minus 15. And then I got to divide everything by 3 to get y by itself. So we will have y is equal to -1/3 x minus 5. Now it's in slope-intercept. Y is equal to mx and then plus b. Right, I know this is the negative sign, but this is actually plus -5. So my slope is -1/3, and my y-intercept is -5. So with a y-intercept of -5, I'm going to go 1, 2, 3, 4, 5, down 5 on my y-axis, and then I'm going to use my slope. I'm going to go down 1 and to the right 3. So down 1, 1, 2, 3, to the right 3. So look at your picture and think and make sure that it makes sense to what you're supposed to have. I've got a negative slope, so it should be going down and to the right. That's what we've got going on. All right, now I want number 10 to be in slope-intercept. So let's add 1, and I'm going to subtract 4x at the same time. So plus 1 and then subtract 4x. So that cancels and leaves me with y. That cancels, and I get -4x plus 1. So here my slope is -4 and my y-intercept is 1. So to graph that, write that down, we'll go to 1 on the y-axis. Then my slope is -4. So this means actually -4 divided by 1. All right. So the rise and then over the run. So down 4, 1, 2, 3, 4, over 1. And then we'll try to draw our line through there. So I've got a negative slope and it's going down to the left. So that's what we should have. Alright, so we're going to write the equations to represent the lines shown. Alright, so this is a vertical line going through 1, 2, 3. X is equal to -3. So vertical lines have an undefined slope, but its equation, you can still represent it with an equation, is x is equal to -3. So whenever you've got a vertical line here, tell me what number the line is going through on the x-axis. If it were over here at 2, x equals 2 would be what my equation would be with this blue line. So that one is x equals 2. Alright, so now I've got a horizontal line going this way, and it's going through 1 on the y-axis. So y is equal to 1. So remember, horizontal line going through the y-axis, just tell me the number that this horizontal line is going to. Y equals blah, blah, blah. All right. So the slopes of parallel lines are equal, and the slopes of perpendicular lines are negative reciprocals. So how do we determine what's what? Well, we have got to solve these things. These equations we're going to solve for in slope-intercept form. So both of these, when I get through, are going to look like y equals mx plus b. So for this first one, 10x plus 5y equals 5. I'm going to subtract 10x from both sides. So 5y equals negative 10x plus 5. Divide everything by 5. And y is equal to negative 2x plus 1. Alright, so this line's slope is negative 2. So let's do it for this one right here. I have got negative x equals 2y plus 16. So what we're going to do, solve it for y. I'm going to have negative x equals 2y plus 16. So I'm in a little trouble. I'm just going to do minus 16 from both sides. So minus x minus 16 is equal to 2y. And now I'm going to divide everything by 2. So y is equal to negative 1/2 x minus 8. So my slope for this line is negative 2. The slope for this line is negative 1/2. So they're not the same number, so they're definitely not parallel. And they aren't negative reciprocals either, because I would need to get a negative 1 for my solution when I multiplied negative 1/2 times negative 2. So we will say neither for this one. We'll do it over here on the side. Neither. Okay, so I'm going to leave it up to you all to figure this one out. I'm going to go ahead and tell you that the slope of this line, m, is equal to 4/3. And I know that because we went and we will solve this thing for y. Alright, so subtract 8x, divide by negative 6. You end up getting 4/3 for your slope. So this one here, after you get this in slope-intercept form, you can pull that slope out of it. You can say m is equal to 4/3. Alright, so same number, 4/3, 4/3. That means we have parallel lines. Alright, so on to the next one. This is a lot of information, really quick, y'all. See what we can do here. Alright, so the point at which the graph intersects the x-axis is the x-intercept. This point here. This is my x-intercept. So the point where the graph intersects the y-axis is called the y-intercept. So right there. So the pink one is the y-intercept, and it's supposed to be blue is the x-intercept. So here we're going to tell our answers in ordered pairs. The x-intercept is -3, 0 as an ordered pair. So my y-intercept is x is equal to 0 and y is equal to 1, 2, 3, 4. So the ordered pair 0, 4 is my y-intercept. So get used to hearing this, because whenever we talk about x-intercepts, we also call them roots, we'll call them zeros, or we call them solutions to the equations. So you don't always need a graph to find your x and y intercepts. All you need to do is remember that if you want to find the x-intercept, you're going to let y equal 0. So 0 is equal to minus 2x plus 5. So this equation is coming from right here, right? So now let's solve it for x. So we'll subtract 5 from both sides, subtract 5, and I have negative 5 is equal to negative 2x. Divide by negative 2, and x is equal to 5 over 2. So my ordered pair for my x-intercept is x equals 5 halves and y is equal to 0. So my y-intercept is going to be this. If I'm finding my y-intercept, I'm going to let x equal 0. So negative 2 times 0 plus 5. So negative 2 times 0 is 0. So y is equal to 5. So my y-intercept is equal to, when x is equal to 0, y is equal to 5. And you could actually graph your line from this right here. You just plot this point on your x-axis, this point on your y-axis, draw a straight line through them, and you can see what's going on with your lines. Any questions? You'll have to wait till tomorrow. Alright, so find the x and y intercept of each equation, then graph the equation using the intercepts. Yeah, there are a lot of different ways that we can solve these and a lot of different methods we can use to graph these things. Right now, what we're learning is finding the x and y intercepts and graphing it from there. There are a host of other ways that we could do this. We're just going to do it this way for right now. So I am going to find my x-intercept first. So x-intercept. Remember, when I want my x-intercept, I set y equal to 0. And I solve for x. So 0 equals 5x minus 1. Add 1 to both sides. 1 is equal to 5x. Divide by 5. And x is equal to 1/5. Alright, so when x is equal to 1/5, y is going to equal 0. So 1/5, 0 is one of my solutions. And to find my y-intercept, I let x equal 0 and solve for y. So y is equal to 5 times 0 minus 1. 5 times 0 is 0. Bring down my negative 1. So when x is 0, y is negative 1. And there is my solution for that one. Alright, so I'm going to flip over and do an example of one that's in standard form. So the one that's in standard form, hopefully you could recognize it pretty quick, is 4x minus y is equal to 8. So let's find the x-intercept. So if I'm finding the x-intercept, I set y equal to 0. So 4x minus 0 equals 8. I'll let y equal 0. Simplify. 4x is equal to 8. Then x is equal to 2. So my x-intercept is x equal 2, y equal 0. So 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. 2, 0. And now let's find our y-intercept. So for the y-intercept, I'll let x equal 0, so 4 times 0, and solve for y. Minus y is equal to 8. So 4 times 0 is 0, minus y is equal to 8. Divide by negative 1 because you want that y to be positive. Y is equal to negative 8. So when x equals 0, y is equal to negative 8. And there is my solution. Oh, we need to graph this bad boy too. Alright, so x is equal to 2, y is equal to 0, so I'm going to go over here on my graph. X is equal to 2, y is equal to 0. So here is 1 point. And then for my second point, x is equal to 0, y is equal to negative 8. So 1, 2, 3, 6, 7, 8, right there. And then connect your lines, or your dots to make your line. And you can see that this has a positive slope because it's going up to the right. Alright, let's do one with fractions. So let's do number 6. So I'm finding my x-intercept. I'm going to let y equal 0. And then we'll have 3/4 x is equal to negative 2. So I'm going to multiply both sides by 4 and then divide by 3. So 3x is equal to negative 8. Divide by 3. X is equal to negative 8/3. So one of my points is negative 8/3 and my y value is 0. So let's do for the y-intercept 3/4 0 minus 1/3 y is going to be equal to negative 2. So 3/4 times 0 is 0, leaves me with minus 1/3 y is equal to negative 2. So I'm going to multiply both sides by negative 3, and that's going to leave me with y is equal to 6. So when x is equal to 0, y is equal to 6. So 0, 6. And there is my other ordered pair. Now let's graph this thing. Get as close as you can whenever you're graphing and you're using fractions. Alright, so this is going to be 2 2/3. So get as close as you can. It's really hard with this small graph paper, so I'm not going to go through here with a ruler and measure them or whatever, but just 2, a little bit bigger than 2, we'll say right there. By the time I get through filling it in, I've about got the whole square filled in. So there's that point. And then 0, 6, x is equal to 0, y is equal to 6, 1, 2, 3, 4, 5, 6. So there are my 2 points. Draw a line, hopefully through both points. And there's your graph. Alright. So you all are responsible for finishing these notes and then at least doing the first page of this. So I feel like I have talked forever. I actually have. Like this. You know what? Do them all. Do them all and just turn in the homework 2 sheet up front. Remember, y'all, I just want the homework sheets. Y'all can keep your notes. I just want the sheet that says homework 2 on it. And make sure you put your name on them so I know who is who. So thanks for watching and behave.